Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important question on operational amplifier, and this question is from May-June 2021, paper 41. For question number 8, the variation with temperature of the resistance of a thermistor is shown in figure 8.1. This is figure 8.1. You can see here on y-axis resistance is plotted and its unit is kilo ohms. On x-axis temperature is plotted and its unit is degree Celsius. For this question, it is also given that a student includes the thermistor and an ideal operational amplifier in the circuit of figure 8.2. This is our figure 8.2. You need to understand the name of these components, mean the names of these certain components. First of all, the name of this component, you need to be very clear with this symbol because this symbol is very common and this is for thermistor. The second symbol you need to understand is this is symbol, and this symbol represents LED, light emitting diode, and this is our output device. These are just resistors as you can see, and this is op amp. For part A, question is asking us we need to calculate the potential V plus at the non-inverting input. Non-inverting input, if you look at op amp, it has two inputs, one with positive sign, that is called non-inverting input. So this is non-inverting input. If V plus is greater than V minus, then V out will be positive. So V out will be positive. So it means current will flow like this. So this is very important. When V out is positive, so means current will flow like this. The second one with negative sign, this is inverting input. We need to understand these things are very important. Even we don't need for this question right now, but you need to understand. So this is inverting input. It simply means if V negative is greater than V plus, V out will be negative. V out will be negative means current, if V out positive, current will flow like this. But if V out is negative, current will flow in opposite direction, means current will flow like this. If V out is negative, so current will flow in opposite direction. So this is very important. You have to be clear with these things. Now let's try to find out what is the value of potential at non-inverting input. If you look at this point and we look at this point, potential at this point, this is equal to 0 volt. If I connect voltmeter across these 2 points, means across this resistor between these 2 points, so the reading on this voltmeter, let's say that reading is equal to V1, and that is the potential at this point. Why? Because this side potential is 0, so the potential difference across this one, that is equal to potential at this point. Now simply we need to find out V1. So V1, simply we can say that, or if you want to write down V plus, we can also write down this is V plus. V1 in this case is equal to V plus. V plus simply is equal to resistance of this resistor divided by the total resistance of this branch. So we can say this is 3 ohms divided by 3 kilo ohms plus 2.5 kilo ohms. We don't need to write kilo because it will be cancelled. Then we need to multiply with this potential difference across these two resistors, and that is 3 volts. If we just simplify this, we will get our final answer, and that is the value of V plus, and this is 1.6 volts. So V plus is equal to 1.6 volts. For part B, at 10 degrees Celsius, the resistance of the thermistor is 2.5 kilo ohms. Question is asking us to state and explain whether the LED is emitting light or not. Simply we need to answer, is it emitting or is it not emitting light? How we can justify that one, it is emitting or it is not emitting light? For that purpose we need to understand, because this LED, it is connected in this way, this is diode, and the resistance of diode in this direction is very low. So if current flow like this, then this LED will emit light. In order for current to flow like this, V out means the V out of this op amp has to be positive. So in that case it will emit light. Simply we can write down it will emit light. On other hand, if V out, let's say if the V out is negative, then current will flow this way, but the resistance of LED is very high in reverse biased, so no current will flow. So when no current will flow, it will not emit light. So simply we can write down does not emit light if V out is negative. So simply we can say it does not emit light if V out is negative. Now we need to find out, is the output of op-amp, is it positive or is it negative? We have calculated value of V plus, and that V plus in part A, that was equal to 1.6 volt. Now simply we need to find out what is value of V minus. The resistance of this thermistor is given now, and the resistance of this one, we can say this is RT, that is equal to 2.5 kilo ohms. Now we need to find the potential at this point. If we connect our voltmeter across this, means across this resistor, and this is one end of the resistor, we need to find the potential at this point, and this end, this is connected with ground, so this has zero potential. So the reading on this voltmeter is simply equal to V minus. Let's try to find out what is potential difference across 5 kilo ohm resistor. So we can say that this is V minus, and this will be equal to 5 divided by 2.5 plus 5. Simply we need to multiply with the potential difference across these two resistors, that is equal to 3.0 volts. In this case our final answer is 2.0 volts. So V minus, this is equal to 2.0 volts. For this question we need to state and we need to explain. State means that we need to write down it is emitting light or it is not emitting light. So we simply write down here does not emit light. So you can say simply no light, or you can say does not emit light. So this is what you need to state, does not emit light. This is one thing you need to write down. We need to explain that why it does not emit light, means we need to write down explanation. So we will explain here now. We have to give reasoning. We need to justify our answer why it is not emitting light. So the first reason you can write down as V minus, means this one. V negative, this is greater than V positive, means V positive. So the second point you can write down, output is negative, so that's the reason it does not emit light. Output is negative, so we can write down here output is negative. State does not emit light. Explain why not emit light, because V negative is greater than V positive and output is negative. For part C, we need to explain why the student circuit will not indicate any change in temperature above 0 degrees Celsius. First of all, we need to understand what does it mean by change and when we will observe change. Change means that LED switch on or switch off, LED switch on and switch off. So simply we can say the change means that LED is on, then LED is off, or LED is off, then it is on. So that will indicate there is a change, and that is depending on change in output, means V out. This change will happen when V out change from positive to negative or change from negative to positive. So vice versa is also true. So it changed from positive to negative, or V out change from negative to positive. When V out is negative, LED will be off, and when V out change from negative to positive, LED will switch from off to on. So means LED will change from off to on. But when output change from positive to negative, LED will change from on to off. Simply we can say this LED is depending on V out, or we can say it is depending on V positive and it is depending on V negative. V positive and V negative, because V positive, if this is greater than V negative, V out will be positive. If V negative, this is greater than V plus, V out will be negative. Now we need to understand what is value of V negative at this point. Means V negative, this value we need to find out. V positive we already have because this is constant potential at this point, because we have to fix resistors here. And V positive, this is equal to 1.6 volts. But for this question it is given to us at 0 degrees Celsius. At 0 degrees Celsius, resistance of thermistor, this is equal to 3.8. So we can write down the resistance of this thermistor is equal to 3.8 kilo ohms. Resistance of this resistor we have because this is a fixed resistor. Now we need to find out the potential at this point. Again, simply we can say if we connect our voltmeter across this 5 kilo ohms resistor, so the reading on this voltmeter, that will be equal to V negative. V negative. Now the question is that how we can find out this. Simply we can write the resistance of this resistor 5 kilo ohms divided by 5 kilo ohms plus the resistance of thermistor, that is 3.8. We need to multiply this one with the potential difference across these two resistors, and that is equal to 3.0 volt. If we solve this one, our final answer will be 1.7 volt. And this is the value of V negative. Now we need to understand, as temperature will increase, question is telling above 0 degrees Celsius. Now as temperature will increase, the resistance of thermistor is decreasing. Mean this number will go down. If this go down, this will go up. So it simply means that the value of V negative will be greater than 1.7 at higher temperatures. Then we can simply write down at 0 degrees Celsius, V negative, this is equal to 1.7 volts, and V negative always will be greater than V plus at higher temperatures, will be greater than V plus at temperatures higher than 0 degrees Celsius. At temperatures above 0 degrees Celsius. It means that we can say therefore V out is always negative. So the V out is always negative. It means that LED is always off. We will not observe any change. LED is off all the time, so we will not observe any change. For part D, the resistor of resistance 5 kilo ohms is changed to a resistor of resistance capital R, so that the LED switches on or off at a temperature of 20 degrees Celsius. At a temperature of 20 degrees Celsius, LED switches on or off. It simply means that V out at this temperature, this is equal to 0, or simply we can say V negative or V minus, this is equal to V positive. If temperature is lower than 20 degrees Celsius, let me write down here, if temperature is lower than 20 degrees Celsius, LED will be on. But if temperature is greater than 20 degrees Celsius, LED will be off. So this is what it is meant by LED switches on or off at a temperature of 20 degrees Celsius. Very important point you need to understand. If you're not clear about this, it will be very difficult for you to answer this question. Now let's try to understand how we can answer now based on this understanding. V negative is equal to V positive. It means the potential at this point, we know the value of potential at this point, this is V plus, this is equal to 1.6 volt, and V negative at this point, this is also equal to 1.6 volts. Next thing, we need to find out the resistance of this thermistor. But if you look at this graph, at temperature of 20 degrees Celsius, resistance of thermistor is 1.8 kilo ohms. So we can also write down here RT, this is equal to 1.8 kilo ohms. For this question, we need to find out this resistance. Now, this is capital R. We need to find out value of this capital R. Now, it's a very straightforward question. It's just simple. Potential divider, we can also connect our voltmeter here. The reading on this voltmeter means the voltmeter across this resistor, reading will be equal to 1.6 volt. Now, if we need to find capital R, simply we need to use potential divider formula and we can find out. So let me write down, let's say the VR, this potential difference across this resistor, this is VR. So VR simply is equal to the resistance of this resistor divided by the total resistance of this branch, that is R plus 1.8, and potential difference across these two resistors, that is 3.0. If we solve this one, we can, first of all, we need to plug in value of VR, that is equal to 1.6. So we have R divided by R plus 1.8, and this is multiplied by 3.0. Now, if we solve this one for value of R, we can find out R will be equal to 2.2 kilo ohms, and that is the answer. That is what we need to find out. We need to find out value of R in kilo ohms. Simply our final answer is 2.2 kilo ohms. Let's try to answer the same question using a different method. We have already discussed potential at this point V negative. This is equal to 1.6 volts. And potential at this point, this is V plus, and that is equal to 1.6 volts. Potential at this point, this is equal to 3 volts, and potential at this point, this is also equal to 3 volts. And potential here, this is 0 volt. Potential here is also 0 volt because they are just connected by one ideal wire. Next thing we need to understand, if we connect our voltmeter here, let's say we connect voltmeter across this thermistor, the reading on this voltmeter, let's say that is equal to V2, and the V2 will be equal to 3 minus 1.6, that will be equal to 1.4 volts. If we connect our voltmeter here, let's say this is V1, and the reading on this voltmeter, that will be equal to 1.4 volts, means difference between these two. And if we connect our voltmeter here, let's say this is V3, the reading on this one will be equal to 1.6 volts. If we connect voltmeter across this resistor capital R, we can say this is our voltmeter for V4, and this reading will be equal to 1.6 volts. Very straightforward one. From here we can say that V1 is equal to V2. Let's say current I is flowing in this branch, and let's say current I2 is flowing in this branch. Then simply we can say I1 R1. Let's say this resistor is R1, this resistor is R2, and this resistor is R3, and this one, let's say this is R4. We can write down this has to be equal to I2 times R2. From here we can find out I1 over I2, this is equal to R2 divided by R1. We can repeat the same process for V3 and V4. For V3, we can write down I1 R3 is equal to I2 times R4. From here, we can write down I1 by I2. This is equal to R4 by R3. Let's say this is equation 1 and this is second. Now, if we compare these two, simply we can write down R2 by R1. This is equal to R4 by R3. So this is ratio between these resistors. Now simply we can use this one and we can find the value of unknown resistor. In this case R2 resistor, simply let me write down here, R2 by R1 has to be equal to R4 by R3. Let's try to write down this formula in a simpler form. First of all, we need to cross multiply. Means we multiply like this and we multiply like this, cross multiply. So we can write down this is R2 R3, this will be equal to R1 times R4. Let's divide both sides by R3 R4, this side also by R3 and R4. Now from here we can cancel R4, we can cancel with R4, and R3 we can cancel with R3. Now this is the simpler form you can use next time. We can also write down like this: R1 by R3, this is equal to R2 by R4. You need to understand this is R1 and this is R3 and this is R2 and this one is R4. It simply means that the ratio between these two resistors is equal to ratio between these two resistors. The value of R1 now we have, that is equal to 2.5 kilo ohms. We can divide by the resistance of this resistor, that is equal to 3 kilo ohms, and resistance of R2, this is equal to 1.8, is already written here. Let's make some space. This is 2.5. Let me rewrite 2.5 divided by 3 kilo ohms and 1.8. This is the resistance of R2. You can see here, divided by R. We can solve this one for R. Our final answer will be 2.2 kilo ohms. So this is our final answer.